All right, this is your 3.6 homework assignment. So this is all about conditional probability. We have a group of sleep study participants who were asked the following question. Do you normally use a screen, TV, phone, computer, etc. within 1 hour of going to bed, and write the answers as a percent rounded to 2 decimal places. All right, so we had age breakdowns here, whether yes, they use a screen, yes or no, and a total of 876 people asked. So true or false? The probability of a participant age 19 to 29 responding yes is about the same as the probability of the participant 30 years plus responding yes. So we're going to compare those two probabilities. So we've got first one is going to be the probability of responding yes, given that the person's 19 to 29. So I'm going to say, I don't know, we'll call this A. This is yes, no. Okay, so we're given A, that they're 18 to 29. All right, so this would be 312, that's our overlap, out of 330, there's 363 total that are in that age group. So that is 312 divided by 396, or 363. This is 0. I'm going to round this to 86. All right, so then let's compare with the probability of responding yes compared to being in group B, 30 years or older. All right, so that's 311 people total out of 513. And that's 0.61 about. Okay, so these are not close. This is false. The probability of a participant age 19 to 29 responding yes is the same, about the same as the participant 30 years or older. No, they're very different. Okay, what is the probability that a person age 18 to 29 responded yes? That's right here, 86%. What's the probability that a person age 30 years or older responded no? All right, so this is the probability of responding no, given that they're in that B group, 30 years or older. Oh, I'm sorry, there you go. So 30 years or older who responded no, that's 202. Divided by the total number of people 30 years or older. All right, so 202 divided by 513 is 0.39, so about 39%. Alrighty. What's the probability that the study participant is 30 or older? So we are going to compare all the 30-year-olds compared to the total, is what this is asking. So 513 people total out of 876. That is 59-ish. 59%. Okay. And then the last one, what's the probability that someone who responded yes is age 18 to 29? So now this is switching the given. So this is saying, all right, let's find the probability that they're 18 to 29, given that they responded yes. All right, so the overlap is still 312. That's from our table. But now we want the total people that said yes, which is 623, as our denominator. So this is 312 divided by 623 is about 50%. 50% chance. All right, next one. A recent poll yielded the following results in this Venn diagram. So we've got, looks like gun owners and Republicans, and then people who are gun owners and Republicans, and then the people who are not Republicans and don't own guns. All right. So the recent poll concluded the following results over here. Okay, among this group, what is the probability of a Democrat or a non-Republican owning a gun? So we've got, let's see, we've got gun owners here that are not Republicans. And so this is the probability of not being in the Republican Party but owning a gun. So we've got 15 people that are not Republicans but gun owners. So that's going to be our numerator. This is like, gun owners, given that they're Democrat, I guess, not a Republican. These are the total people that are not Republicans, anything outside of the circle of Republicans. So 15 plus 41 goes on the bottom. 15 of them are still on the gun of these people surveyed. So 15 plus 41 is 56. Okay, so 15 divided by 56 is about 27%. So among this group, about 20% of the non-Republicans owned a gun. Okay, there we go. What is the probability that someone is both a Democrat and a gun owner? So this is the intersection of Democrat and gun owner is right here out of the total number of people that were interviewed. So we've got the probability of gun owner and Democrat is equal to, we could do, so this would be the probability, this is our product rule of G given D that we just found up here, times the probability of being a Democrat. Okay, which I haven't calculated that explicitly yet. So let's just do this. This is 0.27 times, let's do that. So we've got, these are the people that are Democrats, not Republicans. So that's, what do we have? 56 out of our total. 56 plus 65 plus 30 is our total sample size, 151. So let's do this. I'm going to use the fraction. So we've got, our first probability was 15 divided by 56 times 56 divided by 151. So we get a total of about 10%. This is about 0.1. So what's the probability if someone is a Democrat and a gun owner? 10% in this population. Let's keep going.